Hello, my name is Ethan Haworth,
And I'm Spencer Howell.
and we'll be talking about Kotlin coroutines and how they can be used for parallel programming. So Kotlin was created by JetBrains, and it's a JVM language that is interoperable with Java, and it's now also available as a native language, and it is the primary language used for Android app development. It's touted as being modern, concise, and safe, and below you can see a very simple Hello World program written in Kotlin. So Kotlin coroutines are they allow for asynchronous and non-blocking programming, and they are essentially reusable lightweight threads. They're supported at the language level, and their functionality is delegated to libraries, and they were first supported in Kotlin 1.3 as of October 2018. So coroutines are used as opposed to futures and promises because their model of suspending function is supposed to be safer, less error prone, and more productive for developers than the typical method of futures and promises. And async and await are not even keywords that you can use in Kotlin.
So we're going to jump right into a simple coroutine code here. We see we have a main function, and up here at top, we're calling global scope.launch is going to start a coroutine in the background in the global scope. So what that means is that it's going to end when the program itself ends. So we're going to delay for 1 second, and this is a non-blocking delay, and we're going to print world. So we launch this, but the code is going to continue on, print hello, and then we're going to block the main thread here for 2 seconds, so we're sure that this will complete before we end the function. So this is a pretty standard way to use threads. The coroutines let us improve on this in several different ways. So first, we can run that last blocking sleep as a delay with the coroutine builder run blocking, which is going to allow us to use those same function calls, but it runs it in a blocking manner, which helps with code readability. Now, instead of blocking at the end, which isn't perfect, instead, we can save a reference to that global scope coroutine that we've launched, and we save it as val job. Then after printing hello, we just call job.join to wait for this coroutine to complete and finish before continuing on in our code here. But the main benefit of coroutines come from structured concurrency. So every coroutine builder, like that global scope that we saw earlier, it does provide a scope, a coroutine scope, or we can declare our own coroutine scope. So that means that it's going to enter and exit at defined points. The main benefit here is not every coroutine has to be global scope, unlike a thread, which will always run from the beginning of your program to the end of it unless you specifically stop it. So that we can launch coroutines within the scope of a specific operation, and we're guaranteed that an operation will not complete until all coroutines that were launched in its scope complete first. So it's easy to see when we look at some code like this using structured concurrency. So we have a run blocking scope as our main coroutine scope we're using here. But when we launch a new coroutine that takes 1 second to complete, we don't even have to wait or join or block anything down here because we know that our outer scope will not complete until everything launched inside it has completed. So we know this coroutine will finish after this. This will print first. This coroutine will finish next. And then when everything is done, we'll exit the main function. And this allows us to get pretty complicated with it because we can nest these together. So here's a typical application a developer might create. So here in our function, first, we're going to load an image in the background using a coroutine we launch from our main scope here. So that's going to load in the background. And while that's happening, we create a new coroutine scope that contains all of our server calls. So first, we're going to launch a coroutine off in the background that's going to be fetching data and processing it from the server. And while that's happening, we can go ahead and submit data to the server within the same scope. And we're guaranteed that this will not exit the scope until our launch coroutine finishes. So this will finish, then this will be done, and then we can exit the scope. By that time, our image is probably loaded, so we're able to continue there. We'll display the page at the very end. And again, when we exit this main function, we're guaranteed that all the coroutines we've launched have completed. This makes it really easy to structure complicated dependencies in your parallel code. So of course, there's always more you can learn at the Kotlin Coroutines guide and the Kotlin docs online. And here are the references we used for developing this presentation. So thank you for listening and have a good one.